All right, geometric sequences. So we have actually done arithmetic sequences. We did them a few chapters ago where you look at a sequence of numbers and you can see that you add one number to the next to get each number. For geometric sequence, you're actually multiplying. So arithmetic sequences are a special type of number sequence, and then geometric is the other type. Geometric means you go from one term to the next by by multiplying. And if you look at this first one, we have this 2, and then 10, and then 50, and then 250. And you can see that in order to get from 2 to 10, you multiply by 5. 10 to 50, you multiply by 5. 50 to 250, you multiply by 5. And so you can see very quickly that that's how you would get to your next number in the sequence. For a geometric sequence, your terms, those are the numbers you have been given. And then you have this term right here, common ratio. Common ratio. The common ratio is the number that you multiply by. Sometimes it's going to look like you're dividing, all right? You're just going to put it in a fraction form. So if you were dividing by 2, your common ratio would be 1/2. Your ratio is always what you're multiplying by, So look at this first example. Example 1. Find the common ratio of each sequence. So to find the common ratio here, we are simply going to go from one number to the next and say, what do I multiply by to get to each number? 3 times what equals 12? 12 times what equals 48? 48 times what equals 192? If you look, it's going to be 4. When you have a sequence, it should be the same number, or you do not have a geometric sequence. If you multiply 2, then by 3, then by 4, then by 5, you have a sequence of numbers, but you don't have a geometric sequence. In order for it to be a geometric sequence, that number has to be the same thing all the time. So my common ratio here would be 4, and that would be your answer. You would just say the common ratio here is 4. Let's look at the next one. For the next one, we're going from 80 to 20 to 5 and to 5/4. What are we doing here? We're dividing by 4. And so the way you would write that is you are multiplying by 1/4. So if I multiply by 1/4, that is the same thing as dividing by 4. So you would not want to tell me that your common ratio is 4, because that would make me think that you are multiplying by 4. Common ratio is always what you're multiplying by. So for this one, you would say, well, the common ratio here is 1/4. So if you look and you can tell that it is dividing, your answer is going to be a fraction. Your answer is going to be a fraction if you can tell you're dividing. So go ahead and try check understanding 1. Find those common ratios. All right, so out of these 3, which one's the easiest? B is definitely the easiest. You can very quickly see that you're multiplying by what number? 2, right? So here's what you're doing. You are taking this second term and you are dividing it by the first term. If you know you have a geometric sequence, you are taking the second term and you're dividing by the first term. All right? -6 divided by -3, what are you getting there? +2, okay? So that will apply to all geometric sequences. If you're looking at it and you're going, I have no clue how I'm going to go get from one to the next, but you know you have a geometric sequence, you can simply take your second term, 150, divided by your first term. Now, I will say you want to reduce it, all right? So you don't want to tell me that your common ratio here is 150 over 750. What you want to do is you want to take that number and you want to reduce it. I can reduce those zeros out immediately, right? And actually, if you can't see it, both of those are divided by 15, but if you don't know that, you can divide by something smaller. What goes into 15 and 75? 5 does. So I can divide the 15 by 5, and I will get 3. And I can divide the 75 by 5, and what will I get? Hopefully 15. And then you'll be able to see I can probably reduce it one more time. What goes into 3 and 15? 3, right? Yeah, so 3 divided by 3 gives me a 1. 15 divided by 3 gives me a 5. So that common ratio would be 1/5. 1/5, right? And so based on that, then we'll be able to do C a little bit easier. So if I look at C, I take my second term, which is 6, and I divide by my first term. And all I want to do is reduce it. What goes into 6 and into 4? 2. So I'm going to divide the top and the bottom by 2. And my common ratio here will be 3/2. All right. And then we're going to take that one and multiply by -3 and get an even bigger number, 1458. And so these would be the next 3 terms in my sequence. Once you figure it out, you're just multiplying to get it. All right. You're just multiplying to get it. So go ahead and do A and C. A and C. For 2A, what is my common ratio here? How am I going from 1 to 3 to 9 to 27? Multiplying by 3. So then your next 3 numbers should have been 81, 243, and 729. C, what's my common ratio for C? What am I multiplying by? 2. So my next 3 numbers should have been 17.6, 35.2, and 70.4. 70.4. Sequences, if they don't tell you, you are going to look for a pattern, what's happening. And so when you look at the pattern, you're going to start and say, can I add or subtract, which that's going to be an arithmetic, or multiply or divide, that's going to be a geometric. And so for this first one, -7 to -5, if I were to just check to see if it was a geometric, my ratio should be 5/7. But if I take 5/7 and multiply the 5 by it, I'm not going to get -3. However, if I look at it from addition subtraction standpoint, you can see that from -7 to -5, and -5 to 3, and -3 to -1 is a 2, right? So I'm adding 2 to get there. And so you can look and say, all right, I have to add 2, adding 2. And again, the pattern should work for all of your numbers. If it doesn't, then you don't have the right pattern. So for this one, I know immediately that this is arithmetic sequence, arithmetic. Arithmetic is going to be adding a positive or a negative number. All right. And so I know if I have to add a positive or a negative number that I am doing an arithmetic sequence. And then if you look at the next one, if I were to try to add something, you'll see that it's different numbers, that I'm adding different numbers here. But if I were to look going from 56 to 28, 28 to 14, and 14 to 7, I am dividing by 2 for all of those, which means I can multiply by 1/2 every single time, and I will get the same number, right? Same ratio. So in this case, this is a geometric because I am multiplying. All right. You have other sequences that may have a different pattern, but that means they wouldn't be arithmetic or geometric. So if you cannot add every single time or multiply every single time, it's going to be neither. You have other sequences that happen, but in this case, it needs to be one or the other. First one, 2 to 4 to 6 to 8, you should have gotten arithmetic. You were adding 2 there. B, 2, 4, 8 to 16, you were multiplying by 2. And then 1, 3 to 5 to 7 was arithmetic. So they've given us the sequence here. 2, 6, 18, 54. The common ratio is 3. The common ratio is 3. And so they're setting up some terminology here. A sub n, so this large A with an n represents the sequence. That's just like a function for the sequence, all right? The n is going to represent which term you're talking about. The first term, the second term, the third term, the fourth term, and so on. So if I were to say, well, in this particular sequence, my first term is 2. And we know that because here's the sequence. They gave us 2. My first term is 2. If it's geometric, then I am multiplying to get to my next one. And so my second term here is 6. If my second term is 6, what is my ratio? What am I multiplying by? I'm multiplying by 3, right? So to find that second term here, a sub 2, or the second term, I take my first term and I multiply it by 3. I only do that once because I'm only getting to the very next term. Another way to write that is 2 times 3 to the first power, okay? And then if I look at my third term, so looking at my third term is 18 because I multiplied by 3 again, right? The way I got this third term is I took my very first term, I multiplied it by 3, and I multiplied by 3 again. And that gave me my third term of 18. Another way to write that is 2, 3 to the second power, 3 to the second power. And then if I look at my fourth term, so my fourth term is 54. And how I get my fourth term is I start with my first term, I multiply by 3, 3, and 3. And so I have 2 to the third power. And you'll notice this pattern that is starting to happen here. If you look at all of these, you are going to start seeing a pattern happen where the term that you're looking for, let's say the second term, relates to this power on the 3 or on your common ratio. And so you'll notice that whatever term you're on, this bottom one says the nth term, you end up taking your very first term and you multiply it by your ratio to the power 1 less than the term you're looking for. It's 1 less because we didn't have to multiply the first term by that ratio, right? The first term isn't multiplied by the ratio, but the second term down is. And so this is the formula that happens with all geometric sequences. And that's what you have on the very page. The formula for a geometric sequence is, if I want to find any term in my series, I am going to take my first term and I'm going to multiply by my ratio raised to the power n minus 1. So if I want my 10th term, I'm going to take my first term and I'm going to multiply it by my ratio raised to the 9th power, 1 less than the term I'm looking for. So the nth term represents that by that ace of n. The a represents your first term. The r is your common ratio. And then if you go over here, the n minus 1, that's the term number minus 1 that you're looking for. So let's look at the example. Example 4, finding a specific term in a sequence. It says find the first, 5th, and 10th terms of the sequence that has this rule. And they've given us this rule, ace of n equals 5 times negative 2 to the n minus 1. So if they want the first term, you actually don't even have to solve for anything. The first term is always going to be this number in front of your common ratio. So you don't have to solve anything. For my first term, it's very simple. My first term is always going to be that number in front of that common ratio, or the number that's being raised to the power. Okay? Now for the fifth term, we're actually going to have to plug stuff in. So for this fifth term, if I want to find my fifth term, I'm going to plug it into this formula right here. I'm going to say that equals 5 times negative 2 to the 5 minus 1, which is 4. All right? And then I have to do order of operations. Order of operations tells me to do my exponents first and then my multiplication, right? So my exponent first would be this negative 2 to the 4th power. So negative 2 to the 4th power, right, is going to be negative 2 4 times, right? Should be what? What's negative 2 to the 4th power? 16, right? 16 times 5, all right? So then my fifth term here should be 80. That would be my fifth term. It also wants me to find my 10th term. So if I look at this and I find my 10th term, I'm going to do the same thing and I'm just going to plug in a 10. So I'm going to say the 10th term here is going to be 5 times my negative 2 raised to the 9th power. 9th power. Pay attention to your negatives. If you have a negative raised to an odd power, your answer will be negative, all right? So if I take negative 2 to the 9th power, that's negative 512. It's a big one. Multiplied by 5, all right? And when I do that, I get negative 2,560, which means this is the 10th term of this sequence that they have given me. For the first one, you wouldn't have gotten the last number because that would be a big one. But the first term was given to you. Should have just been 4. That's the first number they give you. And then you should have said 4 times 3 to the 5th power, which would give you 972 there. For B, your first term was given to you. Negative 2 is your first term. And then you would have said negative 2 times 5 to the 5th power, which would give you negative 6,250. So you drop a rubber ball from a height of 1 meter and it bounces back to lower and lower heights. Each curved path has 80% the height of the previous path. Write a rule for the height of each successive path. What height will the ball reach at the top of the 5th path? Okay? So they are saying whatever the height is here is my initial height. And then I am going to take that height and I am going to multiply by 80%. How else do I write 80% if I'm multiplying by it? How would I write that? 0.8. So I'm going to multiply by 0.8 here. And then to find out what happens after that, I'm going to take that second height, whatever that is. That's second height. And I'm going to multiply that by 0.8. And I'm going to continue to do that third height by 0.8. Every time they're saying that it is 80% of the height in front of it. And so this is a geometric sequence, right? My common ratio here is 0.8. That's my common ratio. All right. 1 meter, and they want this in centimeters. So if I have 1 meter in centimeters, how much is 1 meter in centimeters? This is 1 meter. So what is my height? Yes, 100 centimeters. So my initial or my starting number for this sequence is 100. So if I were going to create a sequence for this, my starting number would be 100. And I would multiply that by my common ratio. My common ratio is what again? 0.8. And I raised that to the n minus 1. So if I want to find out how high it is on a specific bounce, I am going to plug in the number of bounces that I'm talking about to that n, right? In this case, they said the height for the 5th path. For the 5th path, if I wanted to find that out, I would do something like this. And that would tell me my height, okay? And so this is an example of a sequence that would work if it maintained, okay, we're saying that it's going to maintain the 0.8 every time. So your equation for this should have been a sub n equals 200 times 0.56, that's your 56%, to the n minus 1.